Hello everyone, so we are back with Leetcode daily challenge, and in this question we need to restore the array from adjacent pair. So for example, the questions says like that there is an array of consisting of unique elements, and but you have forgotten what are the elements in that array. You just have provided with adjacent pair. Like for example, if you take an example of array 1 2 3 4, then the adjacent pairs are given in any order. It can be not in order. So for example, 2 3 is given, then 3 4 is given, then 2 1 is given. So these adjacent pairs are given, and we need to find out that array from those adjacent pairs. So this is the question, and one thing we need to keep in mind that the adjacent pair will be in any order. The order will be not given. So since the order is not fixed, so there can be several answers, and we need to return any one of those answers, right? So let us try to solve this question. So what solution we can think in mind, like that. For example, let us take this example, like 2 1 is given, 3 4 is given, then 3 2 is given, right? So these three pairs are given, and we need to return the array. So what we can do is we need to do step by step. Like first take the first pair, and we can say that yeah, 2 will be there, and 1 can be on right of it or left of it. The order does not matter. We just have to return any one of the solution. So let us write 1 here. Then the next pair is 3 and 4, right? So 3 can be anywhere, and similarly 4 can be anywhere, right? Then the next pair is 3 comma 2, like 3 and 2 are adjacent. So here 2 and 1 are adjacent, here 3 and 4 are adjacent, and here 2 and 3 are adjacent. So the array can be like 4 3 2 1 or 1 2 3 4. The order does not matter. So in this way we have to return the array. So since you can see that here we are making nodes, right? We are making nodes, and we are connecting the pairs, like the adjacent nodes are connected through edges. So what solution we came in mind is we should make a graph of this adjacent pairs, and then we can do a traversal to find the array from that graph, right? So let us move to the solution in detail. So what we can do, for example, let us have a a pair is x y, then y z. Then we can make a graph, like for the x we can have a array of its adjacent elements. So for x here y can be there. If there is another pair like v comma x, then v will be adjacent of x. Similarly, we will make it for all the pairs x y z, and then v. It will be a map of integer to vector in C++. So in this way we can create a graph. Then what we will do, we will do a DFS traversal, and in that traversal, for like we have to take the root, right? For example, we have to take the root. So let us find out what can be the root of our graph. So if we take an example of array 1 2 3 4, here the pairs will be given, like when the pairs will be given, all the pairs, like the elements which are in the middle of the array will have at least 2 pairs. Those will be involved in 2 pairs, but the elements which are in last, like the at the edges of the array, they will be there in only 1 pair. So we need to find the root by checking the pair, like or we can check the graph itself, like the index which has only one neighbor will be the root of the graph. It can be either x, or it can be the last, it can be the first edge, or it can be the last element of the edge, right? So after finding out the root, we can traverse through DFS, and we can then create the array from that DFS. So this will be the solution, and also we have to keep a track of the previous, like parent or previous, we can say it as a like parent. So when we will traverse through DFS, we will check whether our neighbor element is not equals to the parent. For example, if we are traversing from X to Y, then when we will check for Y, we will again get X there in its adjacent array, right. So then the DFS will call again for X, so it will give an infinite recursion. So we have to check whether the neighbor element of that node is not equals to the parent element of that node, right. So neighbor is not equals to parent of that node. So this check we have to implement, so that the DFS will not give an infinite recursion. So let us move to the code, and we try to code out this solution. Right. So at first we will take the size of the adjacent pair. I think don't need the size. Let us make a graph by a unordered map. It will be unordered map of integer comma vector of integer, right. And I will make this as LL or linked list. We can say it linked list or graph, both are similar. And then what we can do is that for each pair, for auto IT, for each pair of adjacent pair, like each pairs, we need to push IT of 0 dot push back IT of 1, like we are pushing each element to the graph. Like for example, here 2 and 3 is there, for example. So for example, 2 and 1 is there, so we are for graph 2 we are pushing 1 to the vector, and for graph of 1 we are pushing 2 to the vector, right. So we are doing this. Then we need to push LL of IT of 1 dot push back IT of 0. So in this process we have created our graph. Now we need to find out the root, right. So we need to find out the root. So to find out the root, what we can check that the vector part of the graph will have only one neighbor, right. So whatever in the edge of the root, like whatever is in the edge, like edge element in the array, it will have the root, it will become the root. So and it will contain only one neighbor, right. So we have to just check the neighbor part of the graph, and if it has only one element, then it will be the root of the graph, right. So for auto IT of now we have to check the graph, and if IT dot second will be the vector dot size equals to 1, then we will make that as root element. So here write root, and here root will be IT dot first, right. Root will be IT dot first. Give me a second. Yeah. And we have to break that loop. Then now we have to do the DFS traversal, and as I said, in the DFS traversal we need to pass the parent, and we have to check whether the current neighbor is not equals to parent. So let us set the parent as let us make the DFS function first. So DFS will be a void function, and we just have to pass the int node, we have to pass the int parent, we have to pass the vector answer. And then what we need to do, we need to first push back the node to the answer array. One thing we have to keep in mind, that answers would be passed by reference, and answer dot push back we have to push the node. Then we have to for iterate all the neighbors, for auto neighbor of the graph of index node, we have to check. First we have to check whether this neighbor is not equals to the parent, then we will do the DFS. In DFS we need to pass the neighbor, then here parent will be the node and here answer will be passed, and in this way we can do the DFS. And to call the DFS we need to first make the vector answer, then we need to call the DFS function with the root. The parent will be integer max which is not in the adjacent pair, and then answer will be the passed, and we have to return the answer. So let us run this code and try to find out whether it works or not. Yeah, it works fine, and now submit the code. Yeah, so there is some error. Let us check out and find out what is the error. Right, so int max answer is root, id dot second row size equals to 1, id dot first will be the break. Let us try to print what is the root here and try to submit the code. Yeah, so the root is undefined. Okay, the error is like we need to we have found the error, we just need we have some braces issue. We need to keep this break inside the if statement, right? We then run the code. Yeah, it works fine. We now need to submit the code. Sure, so this works. Thank you for watching the video. Give us some feedback if there are any. Thank you.